second half. My name's Paul Mardling. I am VP of Strategy for Piksel, which means today I kind of look at technology and the technology landscape and try and work out what we as a company do. My background is development and infrastructure, generally on public-facing websites, so kind of scaling systems out up to tens of thousands, hundreds of thousands, millions of users. So just start with some background on Piksel, who we are, what we do. So Piksel, we're about 650 people, based across Europe and the US. So in the UK, we're about 300 people. Similar in Italy, and then in the US, we've got about 150 people, and the rest are dotted around Europe. In our current form, we've existed for around 3 years. But actually, the companies that came together to form Piksel, we've got 20 plus years of heritage, which is some of what we'll talk about this evening. So what do we do? We design, build, manage, and operate video platforms for some of the world's biggest broadcasters. So in the UK, if you've used 4OD, Sky Player, older versions of ITV Player, 5Player, Piksel were behind that. So we've worked with most of the big broadcasters in the UK, and then across Europe, people like Liberty Global, AT&T in the US. But as well as working with kind of big broadcasters, we also work with some enterprises, so people like Volkswagen, Delta Airlines, Airbus, helping them deliver corporate video. So really the core across all of what we do is video and large-scale distribution of video across the internet, as well as building kind of platforms and software and SaaS services. We also have consultancy, professional services for bespoke work, and we also do managed service and operations. So, yeah, we still own data centers, we still do things in data centers. The co-location business is still hot, believe it or not. But that's what we do, across over 400 customers. So what we're talking about today is really our journey from what we were doing 20 plus years ago to what we're doing today with our product set. So we began this 20 years ago when operating systems sat on physical hardware. Everything was installed by hand. There were automation scripts, but actually, you probably had 4 or 5 servers to run your entire online suite. So actually, at that scale, it wasn't worth it. What happened because of that? Somebody would be off for an afternoon, and somebody would install something in the wrong directory. But because the world was so fragile and brittle, you'd never fix it. And so the machines actually all develop their own personalities, that you'd know that if you're installing that machine, you put it in that directory, but actually you've got to map the route on the other box to somewhere else. And it was great, it was fun. That's what we did it was by hand. You had about 1 person to every machine. It was good fun. Hardware failures were scary. If you lose that box, you've lost 25% of your capacity. It was a scary world. A power supply went, you didn't change these things very often. The other power supply went. It was scary. In terms of scaling capacity, you had what you had. Putting any additional capacity in, you've got to build all of the business case. You've got to purchase the hardware. Hardware used to take months to ship. You've then got to build it. You've got to install all this software that you can't quite remember where it went. It took time. So scaling out a service would generally take 3 or 4 months. Capacity was finite. We were running big internet scale sites. So things like Big Brother with Channel 4, where you would, on the go live night, they'd have cross campaigns on the television. As soon as they call an action on the television, everybody piles online, and your traffic goes up by 5-10 times. So what we had to do was, we literally sat down the week before and made a list of what we're going to switch off, and we'd switch it off line by as the traffic went up, we'd switch off, and pray that we had enough capacity. Then along came virtualization. That's great. We've got all this hardware, but actually we didn't really understand what to do with it to start with. So we were still doing manual installs. You had a templated OS maybe, but then you'd have to patch it, and then you'd install the software on top. And it's still pretty manual. Not as manual as it had been, when we were putting on hardware. Puppet and Chef came along. Things got more automated. We got better at it. But actually, we had commissioning processes it was still taking us hours and hours to commission a new machine. So you decide you want it, and in terms of scaling, hours is no good. You've got minutes. Capacity management didn't really go away as a problem. We were still buying hardware, putting it in data centers, still paying for it, still arguing with the CFO. We're going to need this. He'd say, who's paying for it? Nobody yet, but if we don't have it, people are going to stop paying because we're going to run out of capacity. So it was still, really it wasn't that far different from the hardware world. We could just, some workloads would accommodate with others. We could kind of use better utilization, but really we weren't a long way forward to where we'd been before. Big leap forward, public cloud. So we were pretty early adopters of AWS. We've kind of worked with it since 2008. What we tended to do with public cloud is we didn't actually fall in the mistake of picking and shifting architectures from data center to cloud. We actually developed a lot of hybrid architectures. So a lot of what we had, SANs, relational databases, things that have, now probably do work in the cloud, but certainly 2008, 2009, those things were very hard to put in the cloud. So we developed hybrid architectures where the core of the system, the content management, would sit in data center. There's still be a relational database, but we'd put effectively stateless caching tiers and even business logic out into the cloud where it would scale. This was great because we didn't have to buy all this extra hardware. The pieces in data center were protected by caches. We understood the scaling, and the things that need to scale were out in the public cloud. But the problem then is, CapEx is great because you know what you've spent. OpEx, you don't know what it's going to cost. It scales out. The CFO gets angry because suddenly he's got this big bill that he wasn't expecting. Also with development environments, remarkably easy to spin them up, remarkably easy to forget to switch them off. And we would just get ever-increasing sprawl of development environments, and people would, we hadn't learned to tag things yet. People wouldn't know what was what. People would be scared. If I switch that off, who am I affecting? Who on earth span that up? Because we hadn't got IAM roles sorted out. That's the world we lived in. So what we did around 3 years ago, when we came together as Piksel, is we kind of looked at these hybrid architectures, and this is a diagram of one of the hybrid architectures. Multiple relational databases in there. There's kind of SAN mounts hidden in little boxes that actually turn out to be core to the whole system. And we looked at what do we do to split this apart. We built cloud architecture. We understand it. We know what works in cloud, what doesn't. And we said, sod that. Let's start again. Microservice. We've done a lot of, in the hybrid architecture, we developed a lot of the ideas that kind of became microservices, but we decided, we understand cloud, we will build a cloud-first architecture from the ground up. And so we built what we call a palette, which is a microservices-based video content management and delivery platform. So to date, we've built over 30 microservices in terms of content processing and delivery, principally built in Java and Node.js as the languages. Everything is continuous integration, continuous deployment, pipelines from test to production. We've got complete flows. We have spun up in 2 regions to support customers. So we've got EU West and US East. So we've got full production environments in both. And everything today is deployed as instances. Well, everything was deployed as instances and AMIs. So what were the problems that we hit with that? We'd done it, we built microservices, we'd followed all the practices, and it looked great. Really, the biggest problem is utilization, that the smallest, we're building a production platform, cloud isn't 100% reliable, so we know we need at least 2 of everything across multiple availability zones, and actually the smallest unit of deployment that we end up with is two micro instances for every service. But actually, because we're dual region, we've got 4 instances of everything as our smallest unit of deployment. A lot of services don't receive load all the time. The majority of our customers are in US and Europe, so we've got 8 hours a day where we're not getting huge loads across a lot of the platform. And what we ended up with across the two regions plus development test environments is over 700 instances running. And this was burning cache, and most of these instances were utilized at 5–10%. The other problem was still back to the scalability problem. Although firing up AMIs is relatively quick, and everything was scripted now, everything was templated, it's still taking 5 to 10 minutes to spin up an environment. And in TV land, when you've got seconds to react, that's still too slow. You're still having service degradation and service outages when you have these huge traffic spikes that come in because somebody on the telly has said, go to the internet, go and download this TV program, Game of Thrones is available now, go and get it online. So we started looking at containers and containerization, but there were constraints around what we could do with containers and containerization. So although Docker, over the last 18 months, Docker's come on a long way, and we'd even deployed container platforms before, back in the days when we were using Solaris, and Solaris supported containers, so we actually had experience of container-based platforms. We got things that don't really fit with Docker, so native applications, Spark, Yarn, and you can force them into Docker, but they don't fit well today. And one of our other constraints really is wanting to spin up a whole instance of the platform. So we've got 2 instances up, but we have major customers that, although everything is built to be multi-tenant, we have major customers who still aren't comfortable with sharing the infrastructure with somebody else. They want their own instance. They're comfortable with AWS now, and that in itself has been a battle. They want their own instance. They don't want anybody else's data. They want it completely ring-fenced themselves. So we obviously don't want to spend 3 weeks setting up all of this infrastructure, doing all the configuration. We want to be able to spin up an entire platform. A day or 2 is good. And so kind of looking around that, really, we kind of narrowed it down to 4 real options, which were Docker with Swarm and Compose, ECS, so the container service natively on Amazon, Kubernetes, or Mesos. And I'm now going to hand over to Craig, who actually did the work and can talk you through better in the detail of what we did.
Good evening, everybody. I'm Craig Denner. I'm a senior engineer at Piksel, helping to look after this infrastructure and all the various different pieces of environments and the whole stack to provide a service essentially to our developers and eventually to our end users, which can be across the whole world. So as already mentioned, we started to do the investigations. We had a look through our different options of moving away from instances to various container-type technologies. And it came basically down to the Docker, the ECS, Kubernetes, and Mesos. So Docker, number 1, everybody's heard of it. It's been out there running for, 3+ years, something like that. Probably the last 18 months production ready. I don't know, it depends on your opinions. It's great if you want to provision something that's Docker-based and fits in nice with the Docker ecosystem. It's good for development environments. Everything's nicely contained. You can just pass a package across a Docker package, Docker container, and off you go. It does have its deficiencies, like every system, of course. There's rough edges, in-place upgrades. They're a bit of a pain. Essentially, you have to build a whole new Docker container and switch across. Not a big deal, you could argue, but it's still something that needs to be worked on. And there's no scheduler. You either have a Docker instance that's running or you don't. But the other thing with Docker is that you can, which is more what this schedule refers to, you can't do resource constraints. So you can't say, I want this sort of bunch of containers over here and this bunch over here. And at the time, when we started looking through all this, networking and storage management were definitely a problem. Networking was known to be quite slow and inefficient. They've done quite a lot of tweaks around that, and it's actually a lot better now. And they've actually, I think it was end of last year, they bought a company and were certainly working very hardly towards integrating that and improving their overall networking stack, and I believe it's tons better. We've not actually gone back and revisited that, so I don't know in reality how good it is. And local storage management, as in each container, that basically doesn't exist until the last couple of months, I understand. If you lose your container, you've lost everything that was on it, which doesn't work for things like databases and certain workflows. Of course, we looked at ECS. It's rapidly changing all the time. Every couple of weeks, there seems to be something coming out of it. It's really quite quick, and up front, it looks quite simple and quite easy and quite nice to use. And yeah, it is under certain, if you're sort of aligned with those, it works fine, it's great. We have some problems with it. For the fixed port mappings makes it inefficient for our use, in that if you've got 4 containers, they all have to be on those ports. But what happens if you want to run 8,000 and then you've got, if you want another container to also run an 8,000, you can't do it on the same host. You have to, on the same instance, you have to do it in a complete different set. So it doesn't scale quite so nicely in that sense, which leads to containers ending up underutilized. Again, we're actually trying to cut expenditure all the time, so yeah, it doesn't really work for us, that. Of course, load balancers, they rely on the fixed mappings as well. You've got to have your ELBs tied in with your containers running on the ports, and if they're flexing up and down and around and all over the place, you can't get to your service, which isn't very good for your end users. And at the time, when we looked at this, one of the biggest problems we found was that the actual containers, each container didn't have its own IAM profile, unlike an instance themselves. So it meant that if you had 2 containers on the same instance, they basically had to have the same IAM profile, which potentially meant that you might have had one customer and accessing another customer's data, depending on how you've done all your applications. But actually, that got fixed last week, we noticed. They've made a big announcement about that. So that's no longer a problem, no longer an issue, which is great. And as I've already mentioned, every week, every couple of weeks, things are changing. Now, the other big player in this field is Kubernetes from Google, making massive advances again every week. They're coming in lots and lots of times. It's fast-paced, it's Google, it's big, it's out there, but there's a lot in it. There's a lot of complexity in it, and there's also some serious points of failure. The load balancing, there's only one load balance. If that goes, you've got to wait for another one to come up to get, and you have an outage. Even if it's like 2 or 3 seconds, it's still an outage. Yeah, scheduler only supports random. Referring to what I said before, this is not a time scheduler, this is a resource-based scheduler. It's basically, you've got a cluster and your container could start up anywhere in it. You can't partition parts of the cluster off to say prod, dev, this customer, that customer, or even sort of demos. It comes up anywhere. Along those lines, it only supports the concept of a single data center. So even if you've got your Kubernetes cluster spread across the whole world, it thinks it's actually in one place. So the only way to get around that is to set up multiple clusters, which leads to management overheads, which again, we're trying to cut back on. Yeah, lots and lots of rough edges. It's looking really, really promising as a project, and going forward, it might be something that's great to start using widely, but at the moment, for us, there was too many problems and rough edges. So Mesos was the other one we looked at, and they sort of have, the tagline is basically a distributed systems kernel. So everything in your Mesos cluster is one OS. If you think of it, all the CPUs and all the different boxes count as one CPU cluster. All the memory is kind of bundled together. It can scale out massively, just keep going and going and going. There's no real scale issues, it just goes on forever. There's actually quite a lot of projects out there that use it behind the scenes. I think Azure uses it behind them. Does have a short feature list though, which kind of works to its advantage in the sense you can quickly work out what it does and what it doesn't do. You can sort of tag things in the Mesos world and then sort of say, I want you to do it across over there, which gives you your resource layouts, which is great. Preemption, nice and easy to scale up and down. And you can also do role-based access control, which is fantastic when you don't want your developers to accidentally push to the wrong area, or you don't want your sysadmins or whoever to push to the wrong places, or even the actual containers themselves, they're restricted. And in terms of what we wanted, what we were looking for, it fitted perfectly. It filled all the things that we were looking for. But the problem with Mesos is it's literally just a cluster system. You actually need something to manage it, to put things on there, which is where Marathon comes in. And the easiest way of explaining is it's like an init system for Mesos. It kind of bootstraps things into Mesos. It's quite nice, provides you with quite a lot of a nice GUI, so you can let your sort of business managers have a look on and see how many different applications are running in this environment, that environment. You can log in and destroy things if you want to. You can sort of say, I want you to quickly spin up because I know that so-and-so is about to have a plotline release on TV and, you know, have the EastEnder herd hitting you. Yeah, and it's got a really nice API at the back end, so you can talk to it through automation in the same way that your users can talk to it through a GUI. So you end up with the best of both worlds in that sense. So putting all of this together, having decided to come for Marathon, we actually ended up with a final architecture which looks like this. Now I appreciate that this isn't the easiest one to see, so I'm going to talk through this briefly. You actually end up with your Mesos masters, which for cluster reasons you have 3, which use Zookeeper to keep cluster state. So yes, that means running Zookeeper for those of you that don't like it. They can talk to any number of Mesos slaves, as we call them in our terms. Mesos follower is another term that a lot of people use. And as we've done blocks here, you can resource constrain them in that sense. And that's where your actual work happens. From there, we actually run our containers on them, and you really can't even see that. Even up close where I am, you can't even see that that's written. But these are the actual containers. When our containers boot, our container would be an identity service, or a profile service, or some sort of video service, whatever it may be. That needs to know and pull in certain things from different environments, like database credentials, which are different across your environments. Certainly hope so anyway. We use Vault for that. We use every application or container gets a ID, and then every environment gets a user from that ID. So it enables it to pull only in the details for the environment it's actually running in. You cannot cheat the system and somehow have a production environment pulling a non-prod database password and cross environments. From there, we then have cache nodes, which for us, we found that all the existing ones looking out there weren't working great for us, the ones that came out there, so we actually have got Varnish in that. The ELBs we have at the front, and the internet facing, and we have some private ones at the back end. The front end provide HTTPS termination, HTTP redirects, and whatever else is needed for that particular service. And then we have internal ones for inter-service communication, so that even across region, if a region or part of a service in the region goes down, it can just talk across to another region transparently through the back end, and it'll just kind of work and get on with it, so that we can do maintenance with a particular service and nobody knows about it. All of this backed by a Cassandra ring. So we did the migration, and actually we didn't have too many problems. I think it took about 2 or 3 days to do the actual migration for the majority of our services. We still have a couple of services we'll come to in a sec. Excuse me. Now, developers didn't really notice any difference apart from the fact that we told them they were now deploying across to a Docker container on Mesos. For them, there was no real difference. You know, when they were doing their testing, they still deployed in the same way, i.e. commit to Git. They still visited the same API end. It was great. End users didn't even know it was happening. We just told a couple of business users that it was happening. That was about it. The actual end users out there on the internet, customers, they didn't even know. And of course, as a bonus, deploys take seconds rather than minutes now, which is a vast, vast difference from the hours and even weeks and months, as Paul was referring to at the start. So what didn't go so well, because even the best laid plans is eventually going to hit some snag. Well, the Mesosphere sort of load balancer, it didn't work. It's a bit too basic, a bit too simple. If you think of it as an ELB, it's very, very similar. It literally just passes traffic to the right place. That's about all it does. We looked at other alternatives, of course, HA proxy being one of the big ones out there that everybody is aware of. And we found that we actually hit, or would potentially hit, the same bug that Yelp did. If you Google for sort of HA proxy and Yelp, you'll eventually come across their bug, which describes it in more detail. Essentially, when you're doing deploys, there may be SYN packets, which are just lost. They vanish into the ether, and you end up with customers that are trying to access the platform that have a couple of seconds outage. So not ideal. So, as I mentioned already, we switched to Varnish, which as a bonus gave us caching. So that was, 2 for 1. Can't really lose on that one. Yeah, we use Vault for our secret management. It's great. It's from HashiCorp, I think, from memory. It's pretty good. It's nice and lightweight. It doesn't really cause us any issues. We've actually, as of this week, just written a sort of our own little tool which sits on top of it, which allows certain people to check in and out of Git, and then that then gets put into Vault, so that only key people around the various teams that we have are able to maintain the entries that are in Vault, but nobody else, and none of the services, certainly. The services just have access to Vault. That's it. Yeah, we had to create Vault, which of course is another management overhead, but you know, you have to do something sometimes. We also had to go through and change all of our CI pipelines. We had to rebuild them all, not from scratch, but certainly we had to go right back to the basics. We can still use the same principles for how to run a test and how to save our images so that we can do rollbacks and roll forwards, things like that, but we still had to sort of say, instead of doing this process to deploy onto an instance, we now have to create a container, and we have to start the container. And we had to do things like create CI containers to do our testing in, so that we weren't putting images into production that had build tools on them and things like that. So a little bit more complex problems, but nothing that didn't take a couple of days to sort out, and it's just a case of working through them all. And of course, something you get free with every Docker installation, disk problems. You keep creating your images, you keep creating so oh look, I've run out of disk space. Oops. Yeah, so we had to sort that one out. Again, that's just a question of working out when an image hasn't been used. After a certain amount of time, get rid of it. Docker garbage collection, if you like. And one of the biggest problems from a developer's point of view is bringing a new service online and troubleshooting it. If they create a new service, they think they've got all the requirements set up. They say, right, please deploy, and then my service isn't there. Where's it gone? This is something we can solve, but we don't bring up that many services, perhaps 3 or 4 every couple of months if we need to, and there'll become a point where we're not actually even doing that when we've gotten the service, and it'll just be every couple of months as we need to. So there's no point us making this part of the process easy. So it is still a little painful, because we have to go in and look in the Mesos and Marathon logs to kind of say, oh, you forgot to include this or that. Because it's init time for the process is when it dies. The actual application hasn't started up enough to do its own logging to then be picked up by a standard logger and presented in the dashboard. So yeah, a bit painful, but it's nothing that we can't work around and doesn't become a problem once the system is actually up and running. Results. So we've now got majority of stuff switched across. We do have some things that haven't been switched across, and we're looking at actively rewriting or redesigning them so that they fit in. These are things that were architected with, yes, if I die, I can come back quickly, but they weren't architected in such a way that they would be easy to restart and to pick up where they left off, which is a bit of a pain, but we're sorting it, we're on it. And we actually went to 300 instances from 700, so pretty good. Our end goal, though, is 100. And we're going to achieve this last little bit with, yes, some of the rewrite of the final services we provide, but also by moving some of our internal tooling onto this. So moving it off of containers as well as the services we provide onto it. So our alerting, our monitoring, our CI tools, our build infrastructure, moving it onto it. There is a little bit of a kind of circular dependency in some of those, so we need to think about that to make sure that we don't end up never being able to kind of bootstrap ourselves, or monitoring never telling us that something's dead when it itself is dead. So there's things like that we need to have a look at. But we have gone to a host, or an instance, if you like, when you look in the AWS console, to being roughly around 60% utilized. And this is backed up by kind of what we're seeing, actually, from our usage patterns. And the thing is, we don't actually want to go anything further than that, really, typically, because we actually want to leave a little bit of an overhead for when we have that big bang to quickly scale up into, whilst in the background, we're actually spinning up physical instance, well, I say physical, I mean AWS instances, to then put more containers on. So it gives us the overhead to sort of have that quick scale up, boot up more instances, and then we can scale into them. So yeah, we don't really want to go too much further with our host utilization to allow us to cope with spikes. And our managers are happy with a lower OPEX. They're loving it. Every time we speak to them, they say to us, what you done now? Oh, we've done this, this, and this. Oh, yeah, there's the bill. It's lower this month. And they're like, yes. So, what's next? Well, any more microservices? We're going to put them straight onto containers. Any new ones that have been designed to go straight on it. We're moving more and more microservices across. And we're actually we're going for the sort of full multi-region resilience. There's some logical problems to solve in that, so that we have our own private Docker registry. You actually need that to be distributed as well. You need to have some of that. We do still have Puppet code, which starts up our instances to actually get Mesos on them. So that Puppet code needs to be distributed, so that if a region goes down and suddenly we need to boot another instance, it's reliant on that region that's down. So things like that. We need to solve all those kind of issues. Building our own AMI images, of course, helps boot times. If it's got 99% of the stuff required to run, great. We've actually got our boot times now down to from needing to start an instance to about, I think it's about 90 seconds before it's actually servicing requests. It takes about 3 minutes before it's fully up in terms of, yep, I'm finished doing all of my boot up stuff. But actually after 90 seconds from the kernel starting, it's ready. And I think we're getting a little bit closer every time we do this to sort of 60 seconds, which is great. Global data replication. Of course, if you have a region go down, we kind of need the data still. So we're working on that. And as of yesterday afternoon, we actually have a global data Cassandra ring now. And all we're doing now is we're working through the individual tables, that's not the right word, but I can't remember it's off the top of my head, to actually tell it just to do the replication. So that's just a sort of an exercise of slowly over the next couple of days doing, really. More platform instances, getting more and more things set up, more things spun up. One of the big reasons for us to actually go with Mesos and Marathon rather than go to Docker was we needed to do things that weren't containerized. We have some jobs coming on board for some of our metadata ingest instances, which run through the likes of Yarn, Hadoop, Spark, all these kind of ecosystems. They don't work in Docker, not nicely, but they do run on Mesos quite nicely, because you can tell the Mesos framework, look, there's a job come in, do this. And it goes and schedules it somewhere on your data center, and off you go. But with resource constraints, you can tell it, actually, I want you to do it in production where it's got bigger, faster boxes. So, yeah, that's the kind of things we're working on now to get more platform instances working, more things going in. And we're, as I said earlier, we're migrating more and more supporting services into Docker. Our infrastructure being the main one at the moment, to reduce that from 700 all the way down to 100 instances. So, with that, thank you very much. And is there any questions?
Do you have any questions? Yeah.
Yeah, thanks. Great results going from increasing application density, so you got down from 700 to 300 instances. How did you decide that you'd right-size those instances, the VMs themselves, that you could scale containers efficiently across? And what are you doing to trigger the increase in containers dynamically, and how well do the applications cope when you scale back down again?
Right, okay, so the first question, I think there was 3 questions in all of that.
Yeah.
So I think the first one was, what instance size are you using and why? Yeah. I can't remember the actual instance sizes off the top of my head, but we didn't choose too big, we didn't choose too small, because too big, all eggs in one basket. And it also means that we're less likely to scale quickly, because what we tend to do is we scale by 50% to bang, quick, we just need it. So I think it was something like a C4X large or something like that. I honestly can't remember. How we decide to scale? Mesos treats your whole cluster, or the resources within that, within what you've partitioned off of that bit, and sort of says, right, well, you've actually got 8 CPUs, 8 CPUs, and 8 CPUs, and puts them all together and says you've got 3 lots of 8. And so what it does then is we provide metrics back out to AWS and sort of to the auto-scaling API, and say, right, well, how many of those CPUs are actually used? So, okay, we start another API service, we start another. Okay, we've now actually got 16 of them used, so really we've only got another 8 left, so we should scale now. So that's how we do that. We look at how many CPUs and memory and scale when they've gone above certain thresholds. Does that answer that?
So I think you're using CloudWatch metrics in that case.
Yeah, sort of. We do have some custom logic in around that to decide that. That's sort of our own scripting that we've had to put together, a small daemon that runs on it and continuously reports them back.
So okay, so that was some extra work you had to do. And how well do the applications cope when you scale back down again? That was the
How well do they scale back down again?
Yes.
They're stateless, so they just scale down. We provide, again, the metrics keeps coming in, and when the load that we provide up to it scales down, because Mesos realizes it's not needing quite so much anymore, it turns off the containers, and then of course that means less CPUs used, and so of course we're providing the right metrics, and then it scales it down.
Brilliant. Okay, thanks.
Thank you.
Cool. Any other questions? Yeah.
So could you explain a bit more about your continuous deployment pipeline? So when someone does a commit,
Yeah, sure.
What happens?
Okay, so when someone does a commit, we have a Git hook which triggers our build process. I don't know how many are familiar with ThoughtWorks Go system. Yep, we're using that, and we just have various pipelines which are tied in together. They do unit tests. They first of all build a Docker container, which is built from a base container which we've built, and then just runs inside of that to do the normal CI test that you would from your desktop, really. The idea is that if you can run something from your desktop as a developer, that's exactly what's happening inside of the container. And then once that has passed, the exit code gets passed all the way back up to Go, and then if it's passed, then Go says, great, I can promote this. And then once it's promoted from our sandbox, which is where we do our unit tests, it gets promoted to our integration. And then that then triggers another process which does all the integration testing that's needed for that service. If that passes, it then gets promoted to our production. And then that goes out and deploys. And that deployment depends on the service. Each service has its own set of tests. So some are 5 minutes, some are 30 seconds. But the actual deployment, when it comes to getting it into production, is sort of 10 seconds or so. If that, it's the time it takes for the container to initialize, fail a couple of health checks as it's still coming up, and then once it's passed how many, that's it, done. And that's about 10 seconds worth. And from when we first started all of this palletized process, we were looking at the database tables yesterday. We've done nearly 500,000 different builds, I think, at the moment. It's a crazy amount when you think of actually how long we've been running for. And we've got a deploy trigger as pipeline, as not pipeline, metrics, and which compares to the previous days and so on. And most days it's up on the previous days. We just seem to be pushing out faster and faster. And the more people go on Docker, you see the faster their actual deployments are.
Cool. Any other questions? No? All right. Well, thank you very much.
Thank you.